Welcome back to Algebra 2, Chapter 8, Section 6 in this book. And what we're doing now is we're going to solve equations with logarithms. Now, before we start, I have to remind you of one thing. What can you do in math? Anything you want, as long as you do it to both sides of the equals. Anything, okay? Let that sink in. Anything. All right, I think you're ready now. Okay, so we have an equation. It's wild looking, isn't it? But we notice that there's a relationship between 4 and 8. They are both, you can raise 2 to something to get it. So we can change that 4 into 2 squared, and we can change that 2 into this 8 into 2 cubed, and then it turns out that if you have the same base on both, I'm getting ahead of myself. Okay, then we should straighten this out. 2 times 3x is 6x, and 3 times x is 3x, and 3 times 1 is 3. Now, if you have the same base on both sides, there's a rule that you can cross them out. I love this rule. So those can't cross out, and these drop down, and then I can just solve it. I can do minus 3x to both sides, and then I can have 3x equals 3, then divide both sides by 3, and x equals 1. Wasn't that fun? Okay, how about this one? This one is, the problem is 2 to what power equals 7, and you just have to remember the formula. That you write log, the base goes here, what it equals goes there, and then you do this on your calculator and you can get the answer. So just remember that formula of how to get between these two things that we learned like last time or the time before. I think it was the time before. Okay, how about this one? Well, the first thing I want to do is move that 4 to the other side. He obviously needs to go over here. So I'm going to do minus 4 to both sides, and I get 10 to the 2x minus 3 equals 17. Well, why is this ugly? Because that x is in exponent land, and it needs to come down to numerator land. Well, it turns out, remember what you can do in math? Anything you want. And what I want to do is just stick a log base 10 on both sides. Why do I want to do that? Because if you have log base 10 of 10, you can cancel them out. Remember I told you why do we do these things? So we can cross them out. That drops this down to numerator land. And now I can start saying why is x not alone? It's got a minus 3, so I'm going to do plus 3 to both sides. Why is it not alone? It's got a 2, so I'm going to do divide by 2 to both sides. So this is the answer in log form, or you can do it on your calculator at this point. Okay? How about that one? Well, I've got log base 3 on both sides, so I could cross them out if I stick a 3 on both sides. If you have a base log to that base, you're allowed to mark them out. And doesn't that look better once we got rid of those? Yes, it does. So now I just do it regular. I'm going to gather up my terms, minus x to both sides, and then I'm going to plus 1 to both sides. So 4 equals x, divide by 4, x equals 2. Okay, let's do this one next. Okay, so what do I want to do? I want to get rid of that log 5. It's making things ugly. How do I do it? I stick a base of 5 on both sides. So now it's 5 raised to the log of 5. What can I do? Whoop, cross them out. It's so fun. Now, so on this side, this drops down to numerator land, or it was up, now it's back down again. And 3x plus 1 equals 5 squared. 5 squared is 25. And now I just do minus 1 to both sides, divide by 3 to both sides, x equals 8. Now what about this one? Boy, that one's ugly, isn't it? Well, what I want to do first is I want to get rid of that plus by making a multiply. That's what we learned last time. Then I'm going to get rid of this log base 10 by sticking a base 10 under it and making it an exponent. Then I'm allowed to mark all of that out. And so that drops back down to numerator land, and I have 5x times x minus 1 equals x squared. So that is equal to 100. So then I move it over by doing minus 100. I notice I can pull a 5 out of this. That makes it look better, right? I divide both sides by 5. 0 divided by 5 is 0. So the 5 nicely gets to go away. I can factor this into 5 and 4. Negative 5 and 4. So my answers are 5 and negative 4. But we have to watch out for extraneous solutions. You could put them back in and see if it works, or you could use your calculator. I say check it on your calculator. This is how you do it. You make y1 equal to this. So you type it in exactly, and y2 is equal to that. The answer is where these two things intersect. Remember this for the SAT. There's some crazy equation, you have no idea what it is. If it has an equals, you can make this side y1, that side y2, and where they intersect is the answer. My son Eli answered questions correctly on the SAT that he didn't know using that little trick because he knew his calculator. That's why the calculator is so important. So y1 is this, y2 is that. Graph it, do second trace, go to intersect, and the intersection is 5, so the right answer is 5, and negative 4 was extraneous. Okay, I think this is one of the most fun things we do in Algebra 2. I love the power that I can do anything I want as long as I do it to both sides. So I hope you have fun too, do your homework. Math is great.